Good morning, everyone, once again. I'm back. Waiting for others to join together. Okay. Till 11:25. Till 11:30 we'll wait. Others also let others to join. I think I have showed you the video on the industrial frames, the and also on the site how the construction was done, and I showed you a video on that. Right. Okay. Hmm. Today we'll be doing the theoretical parts on tubular structures. Okay, I'll again show you a video on tubular structures, which are the basics. The theoretical portions are important in your this thing. Now there's now the tubular structures. Why tubular structures? What are tubular structures? Why tubular structures are required? All these things you'll get to know in that video once I show you that video. Okay. Since this is a here only the theory portions we are doing, which is the industrial frames, industrial buildings. We have gone to the theoretical portions. Then again, we have touched those things like what are industrial buildings, how many types are there. Now, on tubular structures also similarly, we will be doing what? Like what are tubular structures, why they are used, what are the advantages. So, okay, so these things we'll know now on this video which I'm going to show you, and then after that I'll show you a simple short, a very short video on why actually it is important for shapes in designing a building. Shape matters. Why the shape matters? That you will see a simple short example on that. Okay, just to get an idea on why shapes are important in any kind of members in a building structure. Okay, and after that I'll take the attendance. I have two classes, right? After this again is 1 p.m. also. 1 p.m. at you. Okay, showing you the video. Okay, wait, give me some time. Okay, then let's start the video on the tubular structures. Like, just go through that. What you will get the idea of tubular structures. What are the tubular structures? Why we are using these? That are advantages, disadvantages, etc. Okay. So let me share my screen with you all. Okay. Okay. So, am I unmuted? Okay. So start with this video. Sound is okay.
ये आपके फोन में लगता है अभी रिस्पॉन्ड है और आप जैसे ये आप देख रहे हैं कि ट्यूबलाइट स्ट्रक्चर है जो कि आपके सिमिलरली का कंप्रेशन में अंदर यूज हो रहा है वो भी ट्यूब है और ओवरऑल सपोर्ट कर रहा है वो भी एक ट्यूबलेस सिस्टम भी है। तो अब हम आगे इसके बारे में भी पढ़ने वाले हैं। ट्यूबलेस स्ट्रक्चर्स होते क्या हैं? बेसिकली जो भी स्ट्रक्चर ट्यूब की शेप में हो और ट्यूब से बना हो उसे हम ट्यूबलेस स्ट्रक्चर कहते हैं सिंपल लैंग्वेज में। यहाँ पे आप देख सकते हैं दो एग्जांपल्स, दोनों ही बीच के एग्जांपल्स हैं। यहाँ देख सकते हैं आप, ये आपका ट्यूब स्ट्रक्चर है। सिमिलरली ये है ट्यूब स्ट्रक्चर शो हो रहा है। यहाँ पे ब्रेसिंग का काम भी कर रहा है और यहाँ पे भी ब्रेसिंग का काम कर रहा है और ओवरऑल स्टेबिलिटी दे रहा है दोनों ही ब्रेसेस को। तो इसलिए हम ट्यूबलेस स्ट्रक्चर यूज कर रहे हैं आजकल। दूसरी बात, ये एस्थेटिकली अपीयरेंस में हमें अच्छे भी लगते हैं। आप देख सकते हो कि एस्थेटिकली इट इज मच मोर गुड लुकिंग देन द ट्रेडिशनल bridges. Why it's a new concept? अब इसे नया कॉन्सेप्ट क्यों है? क्योंकि आप पढ़ते आ रहे हो रूल्स एंड सेक्शन के बारे में, जैसे यार्ड सेक्शन, लाइट सेक्शन, आप स्ट्रक्चर मेंबर भी पढ़ा है, कंपोजिशन मेंबर भी पढ़ा होगा। बट ट्यूबलेस स्ट्रक्चर ये एक नया कॉन्सेप्ट है और ये नया कॉन्सेप्ट पहले टेक्नोलॉजी के साथ हुआ है। पुराने टाइम में हमारे पास तीन इंपॉर्टेंट फैक्टर थे जिसकी वजह से ये कॉन्सेप्ट को बनने में टाइम लगा। वो तीन फैक्टर्स कौन कौन से थे आइए देखते हैं। जो पहला फैक्टर था वो था स्मूथ कट सरफेस। अगर कोई भी ट्यूब है या स्ट्रक्चर है, अगर हमें उसे कट करना होता बीच में से या कहीं से भी, तो हम उसको स्मूथली कट नहीं कर पाते। तो ये बहुत बड़ा फैक्टर था। दूसरा था प्रोफाइल एट द एंड ऑफ ट्यूब, मतलब जो ट्यूब का एंड साइड है वहां से हम प्रोफाइल नहीं ले पाते। हमें डीजल चाहिए, हमें ट्यूब सरफेस चाहिए, ये हम कट नहीं कर पाते थे। और थर्ड था कनेक्शंस, क्योंकि हम प्रोफाइल नहीं दे पाते थे एंड कनेक्शंस पे, तो हम कनेक्शंस भी नहीं दे पाते थे अच्छे से, क्योंकि उस टाइम तक टेक्निक्स नहीं आई। अब जो पहले दो फैक्टर्स हैं, स्मूथ कट सरफेस एंड प्रोफाइल एट द एंड ऑफ, ये जो है ऑक्सीएटरी कटिंग मशीन से जो भी डेवलप हो गई है अब। और उसी तरह कनेक्शंस हैं वो अब वेल्डिंग कनेक्शन से हम उसको जोड़ते हैं। आपने रिवेटिंग बोल्टिंग भी पढ़ा होगा, बट रिवेटिंग बोल्टिंग में क्या होगा कि आपको अलग से वो ट्यूबलेस स्ट्रक्चर पे दिखेगा, बट वेल्डिंग में वो मर जाता है और वो देखने में भी अच्छा लगता है और इसीलिए ट्यूबलेस स्ट्रक्चर अब ज्यादा यूज होते हैं। इम्पोर्टेंस एंड यूजेस। इम्पोर्टेंट क्यों है? क्योंकि जो उसकी इकोनॉमी है वो अनकंपेरेबल है। अनकंपेरेबल क्यों है? क्योंकि जो काम हम ट्रेडिशनल रोड सेक्टर पे कर सकते थे वही काम हम 40 to 50% कम में ट्यूबलेस सेक्टर में काम कर सकते हैं। तो जो इकोनॉमिकल एस्पेक्ट है वो अनमैचेबल है। सेकंड पॉइंट वही है इकोनॉमिकल पॉइंट ऑफ व्यू से कि उसका जो सेल्फ रेट होता है वो घट जाता है या फिर स्मॉल होता है। पावर होने की वजह से हमारा डेड लोड कम हो जाएगा, और डेड लोड कम हुआ बट सेक्शन वही रहा, तो हमारी स्ट्रेंथ भी उतनी ही रहेगी। तो कि आपका डेड लोड कम होता जा रहा है बट स्ट्रेंथ पे कोई इफेक्ट नहीं आ रहा है, वो उतना ही बेयर कर सकता है जितना कि नॉर्मल हाई सेक्शन या एन सेक्शन कॉलम। बट उसकी वजह से बट हमने डेड वेट ज्यादा था, यहाँ पे डेड वेट कम होगा। और उसके यूजेस देखते हैं, ये कहाँ कहाँ यूज होते हैं। जैसे ये कुकिंग सिस्टम में, इंडस्ट्री बिल्डिंग में आप कुकिंग सिस्टम का देख सकते हो। जैसे यहाँ पे भी हम दूसरे सेक्शन देख रहे हैं। दूसरा है वेयर हाउस। वेयर हाउसेज में आप मोस्टली देखेंगे आप दूसरे सेक्टर ही यूज होते हैं, ताकि मिनिमम स्पेस में मैक्सिमम एरिया प्रोवाइड किया जा सके। इस तरह लार्ज स्टेडियम में, जैसे स्टेडियम की छतें होती हैं, उनको भी ट्यूबलेस स्ट्रक्चर से बनाया जाता है। उसके बाद ट्रांसमिशन लाइन टावर्स हैं, जैसे कि आप देख रहे हैं, ये आपका ट्यूबलेस स्ट्रक्चर ही है, तो ट्रांसमिशन लाइन टावर्स में भी यूज होते हैं। उसके बाद ऑफशोर ड्रिलिंग इंस्टॉलेशन, जहाँ से हम तेल निकालते हैं समुद्र में से, तो उसके लिए जो साइट बनानी होती है, वहाँ पे भी हम इस ट्यूबलेस स्ट्रक्चर्स को यूज करते हैं बिकॉज ऑफ इट्स स्मॉलर डेड वेट। तो हम बात करेंगे क्लासिफिकेशन की। अब दो इंडियन स्टैंडर्ड कोड इसमें ध्यान देते हैं, IS 161 एंड IS 806। अभी देखते हैं। तो क्लासिफिकेशन बेस्ड ऑन थिकनेस, तीन क्लासिफिकेशन होती है, लाइट, मीडियम एंड हेवी, एज पर द थिकनेस ऑफ द टूथ सेक्शन। एंड सिमिलरली बेस्ड ऑन व्हील स्ट्रेस, तीन तरह की क्लासिफिकेशन है। ये होती हैं स्टील 35 या YST 222, स्टील 40 YST 25 एंड स्टील 55 YST 32। जैसे हमारी ग्रेड होते थे स्टील ग्रेड FE 415 500 250 या माइल स्टील जिसे बोलते थे। उसी तरह ट्यूबलेस स्ट्रक्चर के भी स्ट्रेस के हिसाब से YST 22 YST 25 या YST 32 कह सकते हैं, या फिर स्टील 35 ग्रेड, स्टील 40 ग्रेड, या फिर ये आपको IS 806 में और IS 15 में इसकी प्रॉपर्टीज आपको मिल जाएगी। और जो हम डिजाइन करेंगे वो भी हम दो कोर्स के बेसिस पे ही करेंगे। अब बात करते हैं इसके एडवांटेजेस। सबसे पहला एडवांटेज है इसका स्मॉल सर्किट रेट, देखने को बहुत कम, सर्किट स्मॉल है तो वोल्टेज भी कम हो जाता है। सेकंड, डायरेक्ट कनेक्शन रिड्यूस डेड लोड। अब जो कनेक्शन करने होते हैं वो हम वेल्डिंग से करते हैं, तो एक्स्ट्रा जो लोड आता है रिवेट्स या बोल्ट्स का, वो रिमूव हो जाता है स्ट्रक्चर से। अब ट्यूबलेस स्ट्रक्चर है वो होलो भी हो सकता है, और जिसका सरफेस एरिया है वो स्मॉल हो जाता है, और इसकी वजह से जो पेंटिंग का काम है या मेंटेनेंस का काम है वो भी कम हो जाता है, जिस वजह से वो इकोनॉमिकल बन जाता है। उसके बाद हम बात करेंगे हाई फ्रीक्वेंसी ऑफ वाइब्रेशन फॉर डायनेमिक लोड। जब हम डायनेमिक लोड्स के बारे में बात करते हैं, जितनी ज्यादा फ्रीक्वेंसी होती है वाइब्रेशन की, उतना स्टेबिलिटी हमें मिलती है, और ट्यूबलेस स्ट्रक्चर में हायर फ्रीक्वेंसी ऑफ वाइब्रेशन मिल जाती है। उसके बाद स्मूथ सरफेस रिड्यूसेस द पॉसिबिलिटी ऑफ क्रूजिंग। अब बात करते हैं स्मूथ सरफेस प्रोवाइड कर रहे हैं ट्यूबलेस स्ट्रक्चर में, तो वहां पे आपका मॉइस्चर या डस्ट इकट्ठा नहीं हो पाता, और इस वजह से कोरोजन की पॉसिबिलिटीज भी कम हो जाती हैं। उसके बाद यूनिफॉर्म डायमेंशन एंड वेरिएबल थिकनेस एज पर द लोड एंड फोर्स रिक्वायरमेंट। आपने देखा होगा कि अगर मल्टी स्टोरी बिल्डिंग्स हैं तो वहां पे लोड की वैल्यू भी डिफर होती है एज पर द स्लोप। बट ट्यूबलेस सेक्शन में क्या होगा कि आपका यूनिफॉर्म डायमेंशन रहेगा, आप उसकी थिकनेस को घटा या बढ़ा सकते हैं एज पर द लोड रिक्वायरमेंट, एज पर द फ्लोर कंडीशन। ये इसका सबसे बड़ा एडवांटेज है, ताकि यूनिफॉर्मिटी है कॉलम्स वो बनी रहे और स्ट्रक्चर देखने में अच्छा लगे। उसी तरह हम जो उसके अंदर होलो स्पेस होती है, ट्यूब होती है, ट्यूब में आप देखोगे जो स्पेस होता है बीच का वो खाली होता है, और स्पेस को हम अच्छे से यूज कर सकते हैं, जैसे टॉयलेट के लिए या वायरस के लिए। और दूसरा तरीका है हम उसके अंदर कंक्रीट फिल करते हैं, ताकि वो एज ए कंपोजिट स्ट्रक्चर करे और हमारी स्ट्रेंथ को बढ़ाए। इसका एक ही डिसएडवांटेज है, दैट इज हाई मैन्युफैक्चरिंग कॉस्ट, क्योंकि जो मैन्युफैक्चरिंग कॉस्ट है, उसको बनाने की जो खर्चा है वो काफ़ी ज़्यादा है। अब बात करेंगे हम ऐसे कंप्रेशन मेंबर ही यूज होते हैं ट्यूबलेस स्ट्रक्चर बिकॉज ऑफ द यूनिफॉर्मिटी इन रेडियस ऑफ वायरेशन। जो रेडियस ऑफ वायरेशन होता है ट्यूबलेस स्ट्रक्चर का, वो यूनिफॉर्म ही होता है। जैसे आप देखेंगे ये एक कॉलम है, ट्यूब है, तो उसका रेडियस ऑफ वायरेशन है वो यूनिफॉर्म है। इस वजह से जो स्टेबिलिटी मिलती है एज ए कंप्रेशन मेंबर वो अनपैरेलल है। जब हम डिजाइन करेंगे तो हमें ये ध्यान रखना है that diameter of the tube should be as large as possible with d by t ratio as small as possible to avoid local buckling। हमें डायमीटर को जितना लार्ज हम कर सकते हैं एज पर स्पेसिफिकेशन हम वो करें, और जो d by t रेशियो है उसको स्मॉल रखें ताकि जो लोकल बकलिंग होगी कॉलम में वो अवॉइड हो सके। Now, code or terms which will be used in the numerical or designing part। तो पहला है कोड जो हम ले रहे हैं IS 1161/2014। सेकेंड इज IS 806/1968। उसके बाद हम टर्म्स जो यूज करेंगे दैट इज इफेक्टिव लेंथ, ये आपने पढ़ा भी होगा, बेस्ड ऑन एंड कंडीशन। जो कॉलम्स की लेंथ होती है, इफेक्टिव लेंथ होती है, वो एंड कंडीशन जो होती है, जैसे होते हैं तो कुछ वैल्यू होती है इफेक्टिव लेंथ की, वो हम यूज करेंगे यहाँ पे। उसके बाद सिलेंडर मैश रेशियो हम यूज करेंगे L/R, और रेडियस ऑफ गायरेशन यूज करेंगे स्मॉल r। परमिसिबल एक्चुअल स्ट्रेस इन कंप्रेशन सिग्मा सी, इसके वैल्यू हम IS 806 और IS 1161 से कलेक्ट करेंगे। उसके बाद इंटरपोलेशन यूज करेंगे और फाइंडिंग आउट द वैल्यू ऑफ सिग्मा सी। और लास्ट में जो हमारा लोड कैपेबिलिटी है या लोड है जो हम कैरी कर सकता है कंप्रेशन मेंबर ट्यूबलेस स्ट्रक्चर में, उसका हम फॉर्मूला जो हम पढ़ते आए हैं दैट इज एरिया इनटू सिग्मा सी, दैट इज द एक्चुअल स्ट्रेस इन कंप्रेशन। तो बेसिकली ये चार पांच चीजें हैं जो कि आप पूरे जाने में कर सकते हैं। अब हम नेक्स्ट वीडियो में हम न्यूमेरिकल सॉल्व करेंगे इन टर्म्स को यूज करके।
Understood this thing, the tubular structures, why they are used, etc. Or you have some problem in this was in Hindi, you may have some problems. It's okay. Next, I will show you one simple video. Let me check. So, what we'll see an example, okay? Like we'll see an example of, we'll learn about some structures, the shapes of structures. You see, the lady has some wooden, these things, okay, wooden panels with her, okay. So now she has taken a paper okay, hard paper. So, and she has given it some shape. You see the shape how it has been made. Now if she's trying to keep the block, wooden block there, you see it's falling, it's not supporting or resisting the load. Okay, this structure, this shape which she has given to the paper, this has not at all taken the load of the wooden block. But now the same paper, if she is making in a different shape, it is she has given a different shape, and then you see she has rolled the paper, and then she has put the sellotapes there. Now it has become like a cylindrical structure. That means a tube kind of thing, tube structure. Let's see now this can hold or not the wooden blocks. Okay. Now the same wooden block, when she is placing here, we'll see whether it is resisting or not, whether it can carry the load of the wooden block or not. Okay. So you see, yeah, it's taking the same block which the other paper, same paper or in different shape has not taken. Now let us see if we can place another wooden block and whether it can take that second block or not. It's heavy. Let's see it can take or not the second block. Okay. There are many wooden blocks. So let's see whether this can be resisted or not. Whether this second number. Okay, it's taking the second number of wooden block also. It's taking the same simple page in tube kind of shape. It's taking. Now we'll try another third one. Just trying the third one and see. The third one also is resisting, or you can say it's carrying the load of that block, the wooden block. It's heavy. Okay. Now the fourth one, if we're trying, oh, it's taking. It's taking the fourth one also. One, two, three, and four. The same page in different shape was not could not take a single one, but this is taking the four number of blocks. Now let's see how much it can take. How many it can take. The load of how many wooden blocks this simple piece of paper can take in different shape. Let's see. Let's see. Yes, it's taking the one, 2, 3, 4, 5. The fifth one also it's taking. It can hold the fifth one also, the same structure, the same page. This one, 2, 3, 4, 5, 6. This is the sixth one, and yes, sixth one is also taken. My God, this is the seventh one, and the seventh one also can be taken, and yes, it's taking 1, 2, 3, 4, 5, 6, 7. 3, 4, 5, 6, 7. Another 1, 2, 3, 4, 5, 6, 7. 7. Now the another one also she's trying, like, let's see whether it takes or not, and yes, it's taking. So many blocks of wood, that same piece of paper in different shape is being taken. Okay, so that you can see the difference. The same page which was in different shape is now taking the load of 8 wooden blocks. Okay, the same paper is taking 8. See, now she has kept her shoes also there, and still it's taking. That means it's so much strong that it can carry. You can just guess yourself how much load it's carrying, and then that triangular shaped, you can see the triangular shape, the same page of triangular shape was not able to carry not a single wooden block. So this is the importance of shapes in structures, in engineering, structural engineering, in different members. When you construct in roll sections or in steel sections, steel roll sections, or this kind of members, tubular structures, what happens? The shape of the member structures members carry or plays a very important role. When you have a cylindrical or tubular structures, they are much more stronger than any kind of structures. So structures, shape of structure plays very important role. The same page you can see with different shape could not carry, but this tubular kind of structure is carrying that much, so many loads. Okay, much more loads than this triangular shape, because it could not take even one, right? So this was the importance of tubular structures which can carry so much of loads. and that's why we sometimes prefer the tubular structures also, and not because of tubular structure. I'm just giving you this example that shape plays a very important role. Okay, shape plays a very important role in structural engineering. Okay, thank you. This was a short example. Okay, very basic. So we have to also find out the shape factors and the shape. We cannot just give any kind of shape to any structures without without giving the capacity of to carry loads. Okay, so we have to keep in mind the shapes of the structures also. Members, structural members, that what kind of shape we are giving and how much they can resist the loads. Okay, so if I stop sharing my screen now. 11, 15, 15. So it will be 20, 25, 40, 45, 50. Okay. So, okay. I think you understood that first video that on tubular structures, it was on Hindi. Let me again show you if somebody has missed that video. Wait, let me show, and I'll also try to explain if it's possible, because since it was on Hindi, let me wait. I am not. For those who did not understand in Hindi, na. So, what are tubular structures? A structure made up of tubes is known as tubular structure. Okay. In simple language, they are telling. You can see the. Wait. See, you can see what are tubular structures. A structure made up of tube is known as tubular structures. Only those who, okay, I'm unmuted or muted. Okay, unmuted, right? Yeah. Those who had problem in maybe in it was in Hindi, maybe you might have problem. That's why I'll just, in short, I'll just explain the same things, repeat the same things in English also. Okay. So these are what are basically a tubular structure. It is made up of tubes known as, you can see here in the bridge foot. Okay, bridges also it is given just to give a good look, and also it can support. Okay, you can see. Okay, this is giving, this tubular structure is giving support to this bridge member, right? Okay,
it's a new concept.
What is it's what's why it's a new concept?
बट फ्यूचर ये नया कॉन्सेप्ट है और ये टेक्नोलॉजी के साथ हुआ है। पुराने टाइम में हमारे पास तीन इंपॉर्टेंट फैक्टर थे जिसकी वजह से ये कॉन्सेप्ट को बनने में टाइम लगा। वो तीन फैक्टर्स कौन कौन से थे अभी देखते हैं। तो पहला फैक्टर था वो था स्ट्रक्चर। अगर कोई भी ट्यूब है जो स्ट्रक्चर है, अगर हमें इसे कट करना होता बीच में से या कहीं से भी, तो हम उसको फोर्सली कट नहीं कर पाते। तो ये बहुत बड़ा फैक्टर था। दूसरा था प्रोफाइल एट द एंड ऑफ ट्यूब, मतलब जो ट्यूब का एंड साइड है वहां से हम प्रोफाइल नहीं दे पाते। हमें केबल चाहिए, हमें ट्यूब सरफेस चाहिए, ये हम कट नहीं कर पाते थे। और थर्ड था कनेक्शन, क्योंकि हम प्रोफाइल नहीं दे पाते थे एंड कनेक्शन के लिए, तो हम कनेक्शन भी नहीं दे पाते थे ऑफिस से, क्योंकि उस टाइम तक टेक्निक्स नहीं आई। अब जो पहले दो फैक्टर्स हैं, स्मूथ कट सरफेस एंड प्रोफाइल एट द एंड ऑफ ट्यूब, ये दो हुए ऑक्सीएटरी कटिंग मशीन से, जो कि डेवलप हो गई है अब। और उसी तरह कनेक्शंस हैं, वो अब वेल्डिंग कनेक्शंस से हम।
So understood why it's a new concept, because you see it's already mentioned, you can easily understand, like before earlier in this new concept, why this new concept was not used before, matlab like the tubular structures, why they were not used before, why we conventional method, like we used rolled steel sections, we used rolled steel sections like I section, T sections, etc. we used, right? So why? Because of these three points, okay, these three important factors, which is the smooth cut surface profile at the end of tube and connections. That means when if we tried also to make some tubular structures or the members of some structure in tube form, there was a problem of smooth cut surface, like we could not cut the tubular structure in smooth surface smoothly, and also at the end of the tube, whichever we are considering the tubular tube kind of members for structure, at the end the profile could not be rough, it was a rough surface, we could not give a cut, smooth cut, because there were no equipments which could do that perfectly, okay. That's why we could not use this. And also the connection problems were also there, that how we would connect the tubular structures with the other members, with the other members of the steel structure, right? But now why we can use tubular structures now, because we have now the machines or the equipment which can cut these tubular structures in smooth surface and make this profile at the end of the tube smooth. And also now the connections, like the welded connections, weldings are coming now, now the different steel members are connected with welding also. So before we had bolting, riveting, etc. So that's why that was difficult for tubular structures to connect to different members, that's why we did not use. But now since we have all the this problems are solved, like we have the machines for cutting these faces smoothly, we have techniques of connecting different members of tubular structure and the other members together with the help of welding, etc. So that's why nowadays we can use the tubular structure concept, okay.
वो जोड़ते हैं। आपने
That is
रिवेटिंग
same.
मोल्डिंग भी पढ़ा होगा, बट रिवेटिंग मोल्डिंग में क्या होगा कि आपको अलग से वो ट्यूबलेस स्ट्रक्चर दिखेगा, बट वेल्डिंग में वो मर जाता है और वो देखने में भी अच्छा लगता है, और
Okay.
इसीलिए ट्यूबलेस स्ट्रक्चर अब ज़्यादा यूज होते हैं।
Now
इम्पोर्टेंस एंड यूज। इम्पोर्टेंट क्यों है? क्योंकि जो उसकी इकोनॉमी है
economy
वो
है,
अनकम्पेरेबल है। अनकम्पेरेबल क्यों है? जो काम हम ट्रेडिशनल में ट्यूबलेस स्ट्रक्चर में काम करते हैं कि स्मॉल होते हैं, डिफेक्ट में फिट प्रोसेस सिस्टम कर जो जैसे कि यहाँ पे।
so importance and uses is what? First importance of this tubular structure is what? Let me see one thing. Okay. Okay, so the first importance is what? The economy is uncomparable. Obviously, because in tubular structures you can use the hollow structure, right? But in other structures, what you will need different members, alright. You will need different materials, members to form that structure to carry those loads. But in tubular structure you can use hollow structure, so you don't require that much of material, right? So it is obviously economical, and it is uncomparable because you don't need different materials for those to form those members or structures to carry those kind of loads. And also it is a smaller self weight, it has obviously, because since you don't require different members or materials to form that particular structural member to resist load, obviously you will the self weight of this tubular structure, since it is hollow, it is lesser than as compared to the other members like beams, columns, etc., which you're constructing RCC. You will require different materials for that, which will increase the self weight of that particular member, right? So obviously the self weight of this tubular structure is lesser as compared to the other kind of members, structural members. Okay, so now the uses are what you, first of all, you can see here in the picture also, it is roofing systems of industrial buildings are, what happened?
यहाँ पे भी हम tubular structure
Okay,
देख रहे हैं.
so you see here the tubular structures and roofing system of industrial building. This is the warehouse. Okay, in the warehouse also you can see the tubular structures here above, and this also as a column it's used. And large stadium arenas, you can see the tubular structures here. This is the tubular structure here which is connecting the other members. We have the transmission line towers also in tubular form. This is the tower here which is used in structural form, sorry, in tubular form. Then also in offshore drilling installations you can see here. Okay, these are tubular structures formed here. Okay, here, right?
Because of this model.
Okay.
तो हम
Now
बात
the
करेंगे
IS codes which are used, those are 1161 and IS 806. Based on the thickness, light, medium, and heavy. Based on yield stress. Okay, this much, this much, this much. This you understood obviously. So advantages is what and disadvantages? Small self weight, obviously.
direct connection.
Direct connection. Okay. Am I audible? Am I audible? Hello? Am I audible? From that time I'm speaking, you're hearing, no? Okay. Okay. Advantages. These are the advantages and disadvantages of your okay. Four. Okay. Advantages and disadvantages. Smaller sulfate already mentioned in the previous slides. Like because you know the tubular structures are hollow in structure in the form structural form hollow. So obviously the sulfate is lesser. Direct connection reduces dead load. Okay. The direct connection will reduce your dead load. This one, direct connections reduces dead loads, because otherwise what happens in different other than tubular structures, you have no direct connections with the different members. Okay, you will have in girders you see plate girders, entry girders, you see the loads are transferred from one form to other form, but in tubular structure directly the load can be applied. You don't need other members to connect. And like you can see in the like you can see in the flat slabs. If you see in flat slabs, we have learned what that we have from the flat slab directly your load is transferred to the, if you have drop in flat slabs, your load is excuse me. Okay, so like in flat slabs, you know, your load is directly shifted from the slab to the a drop, then from drop to the column head, then from column head to again columns, right? So your load is transferred from slab to different forms, like from flats, from slabs to drops, from drops to column head, from column head to columns, right? But in tubular structures you can directly You can directly divide the load. You can directly place the load, and it can carry the direct load. So direct connections will obviously reduce your dead load, because if you don't have direct connections to carry the load, what will happen? You will need different members, and so obviously dead load will increase. Because you see, for example, if I tell you in flat slab, like how we have done, drop will take your load from the drop. From the drop, what happens from the drop to column head to columns, right? But since you are dividing the load from column head to drops to column head to again this one column, you are creating or you are developing some other dead loads. You're giving the extra dead loads of the you are giving the extra dead load which is coming from the drop and the this thing drop from the column head. These are extra dead loads which you are giving to distribute the load. But in tubular structures, you need not do that. You can directly divide the load. You can directly not divide, but you can directly share the load to the tubular structures, and therefore obviously the dead load is reduced, because this another extra members are not required to be built. Okay, the next point, which is the advantage of the tubular structure, is what? Less surface area makes it more economical, obviously. Then higher frequency of vibration. Hello. Oh, okay. Higher frequency of vibration for dynamic loads. Okay. Then we have the smooth surface reduces the possibility of corrosion. In other members, we may not have the smooth surface because of other dead loads which are present there. Okay. Okay.
जब हम स्मूथ सरफेस प्रोवाइड कर रहे हैं स्ट्रक्चर में, तो वहाँ पे आपका मॉइस्चर या प्रोवाइड कर रहे हैं स्ट्रक्चर में, तो वहाँ पे आपका मॉइस्चर या डस्ट इकट्ठा नहीं होता है, और इस वजह से corrosion
Okay, understood. This why this corrosion. Okay, possibility is less because of smooth surface. Then we have uniform dimensions and variable thickness as per the load and flow requirements.
तो वहाँ पे लोड की वैल्यू भी तो बट ट्यूबलेस सेक्शन में क्या होगा कि आपका यूनिफॉर्म डायमेंशन रहेगा, आप उसकी थिकनेस को घटाया बढ़ा सकते हैं एज पर द लोड रिक्वायरमेंट, एज पर द
This is general for every members or structural members, like the thickness we can increase or decrease as per the load. Knowing the load, we construct our different members, right? So we decrease or reduce the sizes of the members. So in tubular structures, we can directly one structure which is a tube, that thickness if we change it's okay. But in different members, like we have to change the dimensions, longer direction, shorter direction, etc., all these things. But since it's uniform, only once you can change the thickness and it's all done, like to carry with respect to the load, okay, and the flow requirements. So this is one advantage. You don't need to see other variables or dimensions.
वो बनी रहे और सबको देखने में अच्छा लगे।
Hollow space utilization, drain pipers, okay. And also another advantage of your this tube structure is what? Because since this is hollow in space, because it has a hollow space, you can utilize those spaces also for your drain pipe, as drain pipers or wires, cables. You can replace, or you can uh, place inside the pipes your wires, cables. You can place them all inside your tubular structure, hollow space, okay, so that you will give a pleasant look to your building or the structure wherever you are making. Otherwise, you need to have in different structural members, what you have to do, if you are not making a tubular structure but different structure roll steel member, what happens? Extra space you need for your drain pipers or wires, okay. But you can utilize, but in case of tubular structures, you can utilize this hollow space also. This is also one advantage, okay, a good advantage.
जो स्पेस होता है बीच का वो खाली उसको वायरिंग
Okay.
के लिए।
Another one is, okay, now the disadvantage, only one disadvantage is that it's
जो manufacturing cost है,
high manufacturing
बनाने
cost.
के लिए
Okay,
लगता है,
because when we construct or the tubes, right, the tubes which we will use, the construction or the manufacture of that tubes is so high. That's why the initial cost is very high for this, but the long run it is advantageous as compared to the other rolled steel members. Okay, because of these advantages which we already discussed. Okay, but only the disadvantage is that it has a high manufacturing cost. Okay,
because of the uniformity and radius of gyration.
okay, mostly the tubular structures are used as compression members, like in a case of beam or as a truss, etc. You can use these tubular structures because they have a uniform radius of gyration. Okay,
Radius of gyration is following.
and then here you see here they have a very uniform radius of gyration here.
The diameter of the tube should be as large as possible with D by T ratio as small as possible. So
This you understood. This thing you understood. The diameter of the tube should be as large as possible with D by T diameter to thickness ratio as small as possible to avoid the local buckling. This you understood, I know.
diameter a large scope for example. DS 116
Codes used are this. The terms which will be used are effective length, then we have slenderness ratio, radius of gyration, permissible axial. These things in combine when in your 6M, I think the compression members we had designed, we have come across this terms: effective length, slenderness ratio, radius of gyration, permissible axial stress and compression. These things you already know how to find out the compression members. Permissible strength we have done, I remember we have done this calculation of the axial strength also in compression members. So these things you already know because since it is used as a compression member, so these things will be obviously required. Okay, these terms are going to come. Interpolation will do this, you have already done. You know how to find out the P, the compressive strength. So this was your tubular structures. Okay, so this was your tubular structures for I had just repeated this thing because it was in Hindi. I think some of you may had problem, that's why I once more I had given in your English also I have explained. Okay, so let me give me your attendance now. Section B 2112 DOS 64 64 65 67 65 present, 67 69
Present, ma'am.
70
Yes, ma'am.
72
Yes, ma'am.
73
73, ma'am.
74 74 present. Rakesh Giba 75
Yes, ma'am. 75.
76 77 78 81 82
82 present, ma'am. 82.
83 83 84
Present, ma'am.
85
Yes, ma'am.
88
Yes, ma'am.
89 Cyrus 91 91 92 93
92 present, ma'am.
present 94
93.
yeah 94 95 96 97 98 100
Present, ma'am. Ma'am, 98.
98 Debojit Bomil 100 102 then we have 110
Yes, ma'am. 110.
10 present 112
Present, ma'am.
115
Yes, ma'am.
116
Present, ma'am. 116.
okay 117 119 121
Present, ma'am. 121.
122,
Yes, Miss. Freddy.
123, 125, 126, 127, 128, 130, 130,
130, ma'am.
yeah,
130.
135,
Yes, ma'am. 135.
137,
Yes, ma'am. 137.
139, 140, 142, 147. Then we have Michael. Michael, I saw present. Tasika, Tasika, Lisham,
Present, ma'am.
Chosen, Chosen,
Ma'am,
huh?
091 present.
Huh? Zero
091 present. 1.
091 Rakesh Thakur present.
Yes. Yes.
130 present, 128 present. Okay. Chosen absent. Okay. Okay. Thank you.